Good morning, everyone. We are going to hold a webinar on some CS creation manipulation and a little bit of rotary positioning. My name is Mario Guerrero, and I'll be holding a series of webinars that we will invite and schedule on our website. The purpose of this webinar is to show you how to create, move, and rotate coordinate systems. What I'd like to do is open our new part, go to my file, reset files, and I'm going to open a part that I had just previously created stock for. It's called a CS part. What we're going to do is work with a 4-inch cuboid, build coordinate systems on all sides of this cube, show you how to get them into position, put a little bit of geometry on 4 of the sides, and show you how to rotary position this part to a machine on all 4 sides. Now this part is being held in a 4-axis vertical mill. The material is your choice, of course. I'm going to go with aluminum alloys in the rot condition and bump the hardness up to 75 to 150 on the H scale, and I'm looking for 6061. It appears there in my selection set. So all the feeds and speeds generated by the system will be consistent with my material selection and my tool material. My input method will be an inch, and my stock is defined as 2 inches in each direction, leaving the default coordinate system in the center. When you select a 4-axis vertical mill, you get an additional icon on the lower left of the stock definition window, and this icon is for rotary axis setup. Click this tile, and you can determine how your part is positioned on the machine. In this case, I'm using a 4th axis mounted on the operator's right as he stands in front of the machine, and this can be toggled to the left side by clicking on the plus checkbox or unchecking it to put it on the operator's right. The axis markers show the positive direction of each axis. X positive to the right, Y positive away from the operator, Z positive upwards. The red arrow indicates the clockwise rotation of the rotary axis, and the Y and Z dialogues determine the center of rotation on this particular setup. When setting up your tools, the tool length offsets are set to the center of rotation, and all the Z values are positive based on the touch-off point being the center of rotation. All right, so that's what we're going to be dealing with here. The clearance plane, 3 inches above center of the part, puts me 1 inch above the defined stock, and any comments that I would like to include with this part can be typed in right here. I'm just typing in 6061 T6. We'll close this dialog window and talk a little bit about defining coordinate systems. Now, we're going to be using these 3 tiles here, the workgroup tile, coordinate system tile, and coordinate system palette. Workgroups, as you all know, contain geometry. Coordinate systems define planar orientation and location. A workgroup can be attached to multiple coordinate systems, and a coordinate system can have multiple workgroups. What the workgroup does for us is it hides or shows geometry as we need it for machining or modification. The coordinate system palette has a series of tiles that perform actions on the coordinate systems. We have the change origin tile, align the horizontal axis of a coordinate system to a piece of geometry, align the vertical axis to a piece of geometry, align a CS plane, whether it's through a series of points or a rotation. And then we have the planar orientation tiles, XY, XZ, and YZ, which control orientation along the three primary planes. Primary planes are designated as XY, XZ, and YZ. When you deviate from a primary plane, we'll replace or substitute one of the call letters for an H, a V, or a D. HVD represents horizontal, vertical, and depth. Depending on how the orientation of the coordinate system is defined, one of the axes can be substituted for a V, a D, or an H. The toggle depth icon. This tile here reverses the polarity of a coordinate system. Now, a very important rule that we must keep in mind when defining coordinate systems is that the tool will always approach a coordinate system from the positive side. If you look closely at the origin marker, there is a positive sign, and if we flip it over, there's a negative sign on the back side. So keeping this in mind, when defining coordinate systems, always point the positive side to the direction of the tool approach. In defining coordinate systems or a four-axis environment, the default coordinate system cannot be modified. As you can see, when I click on the coordinate system palette, none of the tiles activate. It's all grayed out. This is because we're dealing with the default coordinate system. The default coordinate system cannot be modified, moved, or toggled for depth. When you build a new coordinate system, it's done by clicking on the new CS tile, and the new coordinate system is a duplicate of the active or existing coordinate system. So when I click on new CS, I'm not going to see any obvious changes on the screen, simply because I'm duplicating what's already there. Coordinate systems can be named or should be named, and they should correlate with the name in the workgroup. That way you can readily identify geometry that's located in a specific coordinate system by comparing the names. I'm going to close the workgroup dialog temporarily, and we're going to concentrate on coordinate systems and coordinate system orientation and placement. The CS dialog window is accessed by clicking on the second tile down on the right to open and activate the window, or when you want to select coordinate systems, you can click and hold, and you get a pull down to the left of the button that allows you to select and create coordinate systems. For now, we're just going to activate the window and leave it open so we can see what we're doing. The XY plane is the default coordinate system. We have a comment where we can change the name in this column, and we have a WFO column. I'll explain how the WFO column works when we get a series of coordinate systems up there. I'm going to create a new CS. Clicking on new CS gives me a user CS under the comment column. And as I mentioned, there's no apparent change on the screen. The new CS is a duplicate of the existing XY plane. Also, you notice when I generated a new CS, the coordinate system palette activated. Now all the functions are accessible. I'm going to rename this coordinate system. I'm going to call it the top. The reason for calling it top is because it's going to be placed at the top of my 4-inch cuboid. Now to move it, I go to my coordinate system palette, third tile down on the right top level palette, and from here I activate the palette and I go to change origin. The change origin dialog window appears with two radio buttons at the top. the XYZ radio button and the HVD radio button. The XYZ radio button allows us to move the coordinate system in 3D space in an absolute mode based on part origin. HVD is an incremental movement of the coordinate system based on the previous location. So what we're doing is we're changing the origin of the coordinate system. I'm going to go back to XYZ, and I'm going to place this coordinate system at the top of the cube by changing the Z value to a positive 2 inches. X and Y remain the same. Z, positive 2, do it. The coordinate system moves up to the top of the cube, and I now have 2 coordinate systems that I can access from my coordinate system dialog. Coordinate system number 1, click on the name once. It returns to the default location. Coordinate system number 2, top of the part, shows the grid at the top of the part. Now the coordinate system grid can be viewed or hidden by using these tiles in the taskbar. Show stock and origin, hides my material and my part origin. Show CS, shows the coordinate system grid, hides the grid and the markers, shows the markers and the grid, or just the markers only. I'm going to go ahead and leave my grid turned on momentarily so we can see how it looks at the top of the cube. Once you've placed your coordinate system in the proper location, you can then move the origin anywhere within that coordinate system by simply changing the CS origin in HVD or XYZ. Sometimes it's convenient to move the origin for programming purposes. Say I'm programming a part that has all positive values in this orientation, I may want to put my origin marker in the lower left-hand corner. I'll do that in XYZ by going to X minus 2, Y minus 2, do it, and my origin changes to that location. If I was setting a separate work fixture offset for this particular coordinate system, this is where I would touch off my part for the machining of this CS. To return the marker to the center, X0, Y0 goes back to the center. If I wanted to move it in incremental mode, I could turn on HVD, go X minus 2, Y minus 2, Z 0, because this is not an absolute address, this is an actual move. So go to Z0, do it, and the origin marker snaps to the same location. Now to return it, I have to change the polarity. Keep in mind that this is point-to-point or incremental. Putting 0 in this dialog will not force any movement. I have to return the marker to the center by typing in a positive 2 in X and a positive 2 in Y. Do it, and it goes back to the center of the cube. I'm going to go ahead and close this dialog. And we're going to create another coordinate system, but this next coordinate system we're going to place on the front of the cuboid. This CS is going to require different planar orientation, so we'll generate a CS, change the origin and the planar orientation to place it on the front of the cube. So the new CS is generated by clicking on New CS. I change the name of it, call it the front. I want this on the front of my cube. And as you know, the coordinate system that was created is a duplicate of the top coordinate system. So I'm going to change the planar orientation by making it an XZ coordinate system. stands it up vertically, giving me my ZX orientation, X positive to the right, Z positive upwards. Now I'm going to change the origin to place it on the front of the cuboid, and my values are going to be X. I'm going to go back to XYZ. Values will be X0, Y minus 2, Z0. Do it, and the coordinate system snaps to the front of the cube, placing the origin dead center on the coordinate system. Notice that I am keeping the positive vector of the coordinate system away from the cube, controlling the tool approach from outside the cuboid. All right, I'm going to build another coordinate system. This time I'm going to place this coordinate system on the back of the cuboid. Let's build a new CS, rename it back, and change the CS origin simply by reversing the polarity in Y. Instead of Y negative 2, it'll be Y positive 2. Do it, and the coordinate system jumps to the back of the cuboid. I am in the habit of keeping my part in an isometric view because you have to think of your part as a 3D model, or think of it as being in 3D space. So you've got a slightly different thought process. Instead of watching or doing all your work flat, you start thinking of it in a 3D or an isometric mode. Now this coordinate system that we just created has moved to the back of the cube, showing me the markers in the center, but the polarity of the coordinate system is incorrect. If I was to leave this coordinate system as it stands, draw geometry on it, and try to machine it, my cutter would try to go through the part to get to that geometry. The origin must be toggled to show the negative sign on this side. In our coordinate system palette, the last tile is toggle depth. If I click on this tile once, notice that it inverts the markers and shows the polarity as negative to the inside of the cube. So that appears to be correct. Now, the tool approaches from the positive side or outside the cube. So far, we've generated 3 new coordinate systems based on the default. We placed one at the top, one at the front, and one at the back of the cube. I'm going to use a slightly different approach to generate a coordinate system on the right side of this cuboid. Instead of using the change origin tile, I'm going to use the align CS plane. To do so, I build a new CS and I name it right. This is going to be on the right side of my coordinate system. You understand that by building this new CS, we've duplicated the existing CS in its exact location. And now I'll activate my align CS plane tile, bring up the dialog, and see what I have available to me. The default selection is a coordinate system aligned through 3 points in space. The points can be defined as XYZ, absolute coordinates, or HVD, incremental coordinates. By defining 3 points in space, I can generate or align a coordinate system through those 3 points, giving me a compound angle or a skewed CS. The choice that I select to move this CS is going to be rotate. Now the rotate option takes an existing CS and rotates it around an axis to a specific angular location. Now, if I want to rotate this coordinate system to the right side of my cube, I first determine the axis of rotation. I'm going to rotate around the vertical axis. The vertical axis in this case is the z-axis. The z-axis is my vertical axis, and I'm rotating around x0, y0, the origin of the part. My angle of rotation is 90 degrees, and I want to rotate in the clockwise direction. I say, do it, and it rotates into the proper position with the correct planar orientation. This is a YZ coordinate system. The positive side is to the outside of the cuboid, specifying the tool approach coming from the outside of the cube. Now that was pretty straightforward. We made a new CS, we rotated it into position, and we're going to make an additional CS on the left side of the cube. Only this time, we'll take a slightly different approach. Instead of first generating the CS in the CS dialog, I'm going to click on the duplicate checkbox in my CS aligned window. I'm going to duplicate it one time at 180 degrees. So this is going to rotate to the left side when I say do it. And there is the newly created coordinate system on the left side. In the dialog window, the name appears as right mod 1. That's a modification of the right coordinate system. I'll rename it left. And now let's go back and see what we have up to this point. We initially had the default coordinate system in the center of our cuboid. I'm going to close my CS dialog. We created a new CS, moved it to the top. Another new CS to the front. We pushed that one to the back of the cube. Then we rotated to the right side and then the left side. So we've generated coordinate systems on all the faces except for one up to this point. So what we're going to do is we're going to create a coordinate system for the bottom of the cuboid. But to make things easy, I'm going to go back to the XY plane. And the reason that I go back to the XY plane is because it is already in the correct planar orientation. So theoretically, all I have to do is create a new CS, move it to the bottom of the cuboid, and toggle the depth axis. And that's exactly what we're going to do. We're going to click on New CS, rename it to the bottom, change origin, and XYZ, X0, Y0, Z minus 2, do it. And if you notice, I use the enter key a lot. I don't necessarily drag my mouse over the do it button. I can use the enter key to perform the action. The coordinate system moves to the correct location, but once again, my polarity is incorrect. To machine on this CS, I would have to bring my cutter through the part, and that would cause problems. So what I'm going to do is toggle the depth of that coordinate system, and now we see it properly oriented, the negative sign into the cube, the positive sign to the outside of the cube. The way to check polarity is pretty handy. Go back to the XY plane, which is the default, and you've noticed that there are eyeballs to the left of the comment or the coordinate system name. These eyeballs work as they do in work groups. They show or they hide objects. In the coordinate system dialog window, opening an eyeball activates what's called a frame indicator. The frame indicator is a red triad that shows the positive direction of each axis. By going back to my default coordinate system and activating all of the frame indicators and rotating my part around, I can determine if my coordinate systems are properly oriented. Notice that we have a red line extending outwards from the cuboid. That represents the positive depth axis. That ensures that the tool approaches from the outside of the cube. In isometric view, we can get a better overview of what is going on. And you can see that we've properly oriented all of the coordinate systems. Now, once I've verified, then I'll go ahead and turn off the eyeballs, because the frame indicators not only indicate the direction of the axis, but they can be used for toggling between coordinate systems. If I click on this frame indicator, it takes me to that coordinate system. And you can navigate the coordinate systems by clicking the frame indicators. Now, this is really handy, but if you've got geometry on screen and you're selecting for machining or modifying, sometimes the frame indicators get in the way and you end up changing coordinate systems inadvertently. So for that reason, I like to close them. And let me go back to my CS dialog and close these guys. XY plane. All right. So we're back to our original condition. Now, when drawing on coordinate systems, it's typically best to keep the values local to the coordinate system. In other words, build your geometry at depth 0 of each coordinate system. Just like we do in a 3-axis environment where we draw at Z0, we want to draw at depth 0. We always control the depth of the cut with the actual operation or the cutter. I'm going to close my CS dialog and my CS palette and open my geometry creation palette. I want to place some geometry in this central coordinate system. And I'm going to do it with a simple shape, polygon, something basic, 6-side hexagon, distance to flat. Let's go 0.75 and center position 0, 0, 0. We'll say do it, and it places the geometry right on center. Now, this next step is important to understand. When geometry is built in a active coordinate system, it becomes associative with that coordinate system. In other words, the associativity is based on the orientation of the coordinate system. I'm going to open my coordinate system palette and change coordinate systems to the top. When I change coordinate systems, you notice that the color of the geometry changes from a blue connected shape to a magenta connected shape. Now, the color magenta is an indication that this geometry is not associated with the active coordinate system. That's all that it means. You can still modify it, delete it, machine it, move it. The only difference is the color. Geometry can be reassigned or reassociated to an active coordinate system. In the Modify menu are a couple of choices that you may have been wondering about. Change CS XYZ and change CS HVD allow you to control the association and placement of geometry from CS to CS. If I want to associate this geometry with the top coordinate system, the method for doing this is double-clicking the geometry, going to the Modify menu, and selecting Change CS XYZ. When I do so and deselect the geometry, you notice that the color has changed to blue, and it is now associated with the top coordinate system. And I can prove this by moving the origin, and you'll see the geometry move with it. Open my CS palette, move origin tile, and I'll move the origin. Let's move it in HVD X minus 2 inches. And you notice how the geometry snapped with the origin. That is indicating association to the coordinate system. Move it back, X positive 2, and it goes right back. So now what we did is we associated this geometry with the top coordinate system. If I go back to the XY plane where I originally drew the geometry, it is now magenta, showing me that it's not associated with this coordinate system any longer. I'm going to reassociate it. Double click on it, modify, change CS XYZ. This changes the color back to blue and indicates it is now associated with the central or default coordinate system once again. The other choice, change CS HVD, and you notice that they're grayed out until you select geometry. Change CS HVD will move the geometry into another coordinate system. I go to my front coordinate system this time. Now, the two choices are change CS XYZ, change CS HVD. Change CS XYZ, which we've used previously, associates geometry to the active CS without moving the geometry. It stays in its same location, but associates with the active coordinate system. The other choice, change CS HVD, will physically take the selected geometry and move it into a coordinate system. And to illustrate this, I'm going to double click the geometry, and you notice that I've changed CS to the front. My intention is to take this geometry and move it to the coordinate system that's active. Select the geometry, modify, change CS HVD. As you can see, the geometry snaps to that coordinate system and changes color to blue. The relationship of the geometry to the origin of the coordinate system is maintained. In other words, in the XY plane, it was drawn, I'll do it again, put it back, it was drawn at X0, Y0. In the new CS on the front, I want to place this with the same relationship to the origin. It'll be at Z0, X0. Modify and change CS HVD. And it moves to that location. Now geometry can be duplicated and moved to a different CS. For example, if I go to my top CS, double click my geometry, modify, duplicate, or a Control D. You know the keystroke for duplication is Control D. duplicate. It has duplicated the geometry. I go back to the Modify menu, change CS HVD, and it places that geometry at the top. So it took the duplicate and associated it and moved it to the top CS. We'll do the same on the right side. Double click on it, modify, duplicate, modify, change CS HVD, and that geometry snaps to that location. Okay, so I'm going to delete these two hexagons. Another method for navigating coordinate systems is if you have magenta geometry, you can right mouse click it and change CS, in this case to number 2 at the top. And that's another way to get the coordinate system activated based on the geometry. All right. So we've created CSs. We've placed a piece of geometry in one CS. We've associated it to other CSs and physically moved it into other CSs. Now, the WFO column. The WFO column can be used for assigning work fixture offsets. In the default condition, the default coordinate system XY plane is G54. G55, G56, G57 in order of creation. In a Fidel style machine, you have E numbers. Most other formats use the G54 so for Nook style work fixture offsets. Now, if you want to deviate from the default sequence, 54, 55, 56, 57, 58, 59, and so on, in the WFO column, you can type in a number. The number 1 is the first work fixture offset. The number 2 is the second. The number 3 is the third. And that's the numbering convention. So if I want this second coordinate system to be a G56, I would type in the number 3. This would force a G56 for this particular coordinate system. And my post processor would generate a G56 when it machined on the top of the part. If I want to mix them up, I could put another number here, make this number 6. And that would be my G59 coordinate system. In the case of having more than 6 coordinate systems, we can keep on numbering, and the post will give you the G54.1, G54.2, or whatever numbering convention your particular machine control uses. So this is just a handy method for controlling the output from the post. All right, let's close the CS dialog and go back to the top CS. Now, when machining geometry, we can draw the geometry at the top and machine it anywhere we like around the 360 degrees rotation of our part. For this particular illustration of rotary positioning, we're going to make a cutter, do a pocketing operation to this hexagon, and machine it on the front of the cube. Even though the geometry resides at the top, we're going to perform the machining on the front, and then we may even duplicate it to do it on the bottom and the back. Okay, isometric view, close my coordinate system palette, and I'm going to open my tool list and cam list. Tool number 1, finish end mill, and I'll make this tool a 1/4 inch end mill with a 10/1000 corner radius, 2 flutes for plunging, and I'm going to use a tool holder Distance out of the holder, 0.625, and give myself 0.5 flute length. And change holders. There you go. This one a little bit more to my liking. I can zoom tool, take a look at the tool, or tool and holder. Forward spindle direction, tool material. Let's go with the titanium nitride coated high-speed steel. And the comment will be pocket. Nice and simple. Close the dialog and hover my cursor over the tool. I see that my comment is reflected by the cursor. It says pocket. This tool is going to do the pocket. Drag it down. Bring down the roughing tile. Place it on top of that. And I'm going to select an offset pocket. Entry feet of, RPMs of 3,000, entry feet of 10, country feet of 20, cut width 115 is a default to the radius of the cutter minus the corner radius. Half the cutter is 125 thousandths minus my 10 thousandths corner rad gives me 115 thousandths cut width. Entry line of 30 thousandths. Entry line introduces the G41 command on the last pass of my pocketing operation. Without an entry line, I can't turn on cutter radius compensation. It's essential that it has an entry line for G41, G42 to be activated. My 90-degree radius, 30 thousandths. Keep it nice and small and inside of a pocket. Pocket, island stocks are 0, Z stock. I'm going right to finish. Overlap. Maybe I'll give it a 10 thousandths overlap. This will bypass the entry point by 10 thousandths before arcing off the cut. No spring passes. Top of the, or the rapid approach move is based on the coordinate system at the top of the part. As I mentioned previously, we're keeping all the values local to the CS. The start would be 0, retract 0.1, and we're going minus 0.25 deep. And I think I'll split that in 2 passes. Retracts is on, depth first, and prefer subs. Prefer subs will force a subroutine for my multiple pass cut and call it out twice. Hit flats is a option for solids machining. Round corners should always be turned on, regardless of whether you're doing a corner break or not. If you're not doing a corner break and you want sharp corners, make your break 0. But round corners gives you a cleaner tool path. It tends to drive the cutter around corners instead of bypassing the corner before it changes direction. So you get a nice cleaner cut around the corner. CRC stands for cutter radius compensation. This will be on. And I want to do this as a climb cut. You would think that we're ready to machine at this point, but we're not. We need to go up to the Rotate tab. In the Rotate tab is where we have control of where the machining is to be performed. If I go to the pull-down menu, I select the top CS. This will localize all of the values to that coordinate system. The angle is 0, and let's cut it at 0 to illustrate what happens. Put this out of the way here. Select the geometry and do it. The operation appears on the right, the tool path appears on screen, and if I render it, I get the machining. In version 9, in the Flash CPR, if you want to see the geometry, you can right mouse click the top of the control panel and say Overlay Geometry. This will put the geometry superimposed on your rendered image, and you can actually leave it there, and watch your cutter and the geometry at the same time. If you don't want to leave it active, you can turn it off, and you can always go to the view menu and say show geometry, and it'll do the same thing. But if you use that method, the minute you move it, it deletes or erases the geometry. So sometimes I like to use the overlay geometry to ensure that I'm staying within the cut and that I'm, cutting correctly. All right, this cut was performed with the angle at 0. Now, I mentioned that we want to machine this on the front of this cuboid. So I'm going to change my angle to a -90. Now, you're thinking, why -90? If the front face is the positive side, why do we want a -90 in the angle? The reason is that in Gibbs space, we are telling it which way to rotate. So in order to bring that positive face up, if you remember the 4th axis setup, positive rotation was towards the operator. If I was to make that value a +90, I would do the machining on the back side because it would rotate forward. By typing in a -90, it'll rotate backwards. If I redo the operation, you see where the machining takes place. Turn rendering back on, and there's my machining. Even though the geometry is placed at the top, I can perform the machining on the front by changing the angle. We can duplicate and rotate the cut. Let's do it 2 times every 90 degrees. Redo it, and there's the result. We're going from the front to the top to the back. If I change that angle to a +90, redo it, we've reversed the cuts to the front, the bottom, and the back. I can make my angle 0, duplicate it 3 times, and I should get it on all 4 sides. Now when I render it, I anticipate a problem. Here's my problem. The problem is that my retract is too low and it clips the corner of the part as the rotary axis rotates to the next CS. To correct that, I'm simply going to raise my retract plane, redo it, and now I don't have that problem. So this is a very important situation that you have to monitor, is ensure that your retracts are high enough to clear the corners of the part. In our manuals, we have a formula that we provide for you to calculate the exact height of the corner, so you can use that to set your clearance planes. Okay, I'll go back to the Rotate tab and make this 0 once again. Close this and redo it. For subsequent machining, I'm going to turn off my tool list and cam list, and I'm going to draw some more geometry. To get the geometry, we change coordinate systems. We go to the front. Once the coordinate system is active, you can use it as you would the, the basic XY plane. Think of these coordinate systems as individual XY planes that you program on. In the view control palette, we have the home view and the top view. The top view is looking at the stock from the top of the part. The home view is the normal view of the coordinate system. In other words, the perpendicular view. Whenever you want to see that coordinate system displayed flat on screen, you would go to the home view. By going to the home view, we can then program as if it was laying flat. And I'm going to put some more geometry on there. Let's go with the shape. Keep it simple once again. Ellipse. Let's go next radius 0.75, 0.375, x0, z0. And now you notice that you have a different call letter here. You got a D for depth. The depth axis is always into the work. XZD is going to place this right at the coordinate system surface. So you do it, and there's our ellipse. And let's go with a little bit larger. Maybe make it a 1 inch and 0.5. Do that. It looks a little bigger. Close this, and open our tool list and cam list. Deselect the operation. And if I click on the ellipse and say do it, I don't get any toolpath. The reason is that in the process dialog, it is necessary to change the rotate tab to reflect the front CS. Now, when I say do it, I get my operation correctly machined on the front of the all right. There we are. So now you can see how we apply machining to different CSs. Once more, let's put some machining on the bottom CS. But this time, we're going to do it slightly different. As I mentioned, work groups play a role in the geometry viewing, and they are affected by the active work group. For example, work group number 1 contains the geometry for the top and the front. We'll make a new work group and name this bottom. The bottom work group is going to correspond with the bottom CS. In the bottom CS, I'm going to place some geometry, and once again, keep it simple. Let's do a polygon. Let's make it 9 sides, same values. 750 distance to flat, H, Y, and D, 0. Once again, you notice it's not X, Y, and Z. It's H for the horizontal axis. The Y remains as a primary axis, and the depth is the into the work axis. We'll say do it, and it creates that polygon. Home view brings it visible, and if I change work groups, I don't see that geometry. So in order to machine that geometry, I need to have my work group active to show it. And now I can go in and machine it. Open my tool list, and my cam list. Select the geometry, and as you know, when you got a connected shape, simply selecting one portion of the geometry will identify the entire shape. Go to my process dialog, rotate, got to select the bottom CS, and this 90 here makes no difference as long as duplications are 0. I could have any value here and it won't affect anything. But to keep it clean, I'll make that 0. I'm machining in the bottom. Do it. And there is the machining on the bottom of the cuboid. And we'll go ahead and put something on the back side of the cube also. Once again, work group, new work group to segregate the geometry. This is the back side. Open my coordinate system list, select the back, home view, and to keep it simple, we'll do another shape, 3 sides. Do a triangle, and I want to rotate my triangle to keep one of the points upwards. Take this, modify, 2D rotate, 0, 0. Let's go 30 degrees and 30 more. There we go. I can then machine this by simply changing the CS in the rotate tab. Now, I didn't bother changing any of these values because they all remain the same. I was applying the same cutting conditions to all the pieces of geometry. The only difference is that they were located in different orientations or different coordinate systems. So by doing this, selecting the geometry and saying do it, I've got a cut on the bottom of my cuboid. Render it. And there we are. Simple CS creation, placement, and basic rotary position machining. Now, this webinar was intended to cover only the basics. We will be holding more advanced webinars in the future. My intention is to lay down the groundwork, get all the basics recorded so that you gentlemen at your leisure can go through the basic videos and then use the ones that help. And if you have new employees to train, direct them towards the videos, and we'll be glad to put more up there. In time, I plan on having all the lessons recorded and on the website for download. I have a large number of attendees, so I'd like to ask a favor of you guys. If you have any questions regarding this webinar, please direct them to support@gibbscam.com. I get into a situation where I start answering questions here and I get so many of them that some of you guys get tired of waiting for an answer and you log off and I never get to you. But by directing your questions to support@gibbscam.com, I'll be able to take them at a more leisurely pace and answer them all. So look for us in the future. We will be holding more. Thank you very much for taking time out of your day to attend this webinar. And I would appreciate any positive and even negative feedback from any and all of you guys. Thank you for attending.